Have you ever sat in an airplane bathroom, looked down at that blue water, and thought about where it all actually goes? Most people push the flush button and immediately stop thinking about it. The noise is dramatic, the suction is violent, and then it is just gone. But gone where exactly? Because you are sitting in a metal tube at 35,000 feet, traveling at close to 900 kilometers per hour, and whatever just disappeared has to go somewhere. Today, we are going to break down exactly what happens from the moment you press that button to the moment the aircraft lands. And I promise by the end of this, you will never press that flush button again without knowing precisely what you set in motion. Let us start with the assumption most people carry without ever questioning it. For decades, the popular belief was that airplane waste was simply dumped overboard during flight, released into the atmosphere somewhere over the ocean or the countryside below. That belief is wrong, but it did not come from nowhere. Early commercial aircraft, operating before modern waste systems existed, did in some cases use far more primitive arrangements. The technology has changed completely, but the myth has proved remarkably durable. Here is what is actually happening inside that bathroom. The modern aircraft toilet does not use water the way a household toilet does. A standard home toilet uses several liters of water per flush to push waste through a pipe using gravity and water pressure. That system is completely impractical on an aircraft. The weight of the water alone would be a significant fuel cost across thousands of flights, and gravity changes depending on the attitude of the aircraft, making a water-based gravity system unreliable at altitude. Instead, aircraft use what is called a vacuum toilet system. The principle is simple, but the engineering behind it is not. When you press the flush button, a valve at the bottom of the bowl opens briefly. The pressure difference between the low-pressure waste tank and the cabin air pressure creates a powerful rush of air that carries the waste away at high speed. That is the noise. That is the suction. The whole event takes roughly 10 seconds and uses less than half a liter of water. A household flush uses 10 times that amount. The efficiency of the system is one of its most important qualities because every liter of water saved is weight saved, and weight saved is fuel saved across every single flight. But where does the waste actually go? Every aircraft has one or more dedicated waste tanks built into the fuselage, typically located in the lower section of the aircraft near the tail. These tanks are sealed, pressurized containers designed to hold the collected waste from every toilet on the aircraft for the entire duration of the flight. On a short-haul aircraft with a handful of lavatories, the tank capacity is relatively modest. On a long-haul aircraft like the Airbus A380, which can carry over 500 passengers on a flight lasting up to 16 hours, the waste tanks are considerably larger. The engineering team that designs these systems has to calculate the maximum possible usage across the maximum possible flight duration and build in a margin beyond that. Running out of capacity mid-flight is not an option. The blue liquid you see in the bowl is not water. It is a chemical solution called SkyChem, a proprietary disinfectant used almost universally across commercial aviation. It serves several purposes at once. It suppresses odors inside the tank, which would otherwise make the aircraft cabin deeply unpleasant, given that the waste system is not entirely airtight from a smell perspective. It helps break down solid waste to reduce the volume and viscosity of the contents of the tank. And it provides a visual indicator of cleanliness inside the bowl itself. The vivid blue color is partly functional and partly psychological. A blue bowl reads as clean. A clear or discolored bowl does not. Now here is the part of the process that most passengers never think about at all. When the aircraft lands and parks at the gate, one of the first ground operations to begin is waste servicing. Before the cleaning crew boards, before the catering truck arrives, before the fuel bowser pulls up, a specialist waste vehicle approaches the aircraft from below. It connects to a dedicated service panel on the exterior of the fuselage, typically located on the underside near the tail. Through that connection, the contents of the waste tanks are pumped out under pressure into the service vehicle. The tanks are then flushed with clean water, and a fresh charge of the blue chemical solution is added. The entire process takes around 15 to 20 minutes on a standard aircraft and has to be completed before the aircraft can be turned around for its next flight. The waste collected by the service vehicle is then transported to a designated treatment facility at the airport. Airport waste handling is tightly regulated in most countries. The contents cannot simply be discharged into the local sewage system without processing, because the chemical composition of aviation waste, combined with the Skycom solution, requires specific handling. At larger airports, dedicated treatment plants process the waste on site. At smaller airports, it may be transported by road to an approved facility elsewhere. What happens at the treatment plant mirrors what happens to municipal sewage, but with additional steps to neutralize the chemical components of the disinfectant solution. The solid and liquid components are separated. The liquid is treated and filtered. The solid component goes through a digestion process that reduces it to a form that can be safely handled, and in many cases used as agricultural fertilizer. The water that emerges from the treatment process is cleaned to regulatory standards before being discharged. Nothing from that blue bowl simply disappears. It moves through a chain of handling, treatment, and eventual reuse or safe disposal that is more tightly controlled than most people would ever guess. But here's something that does happen occasionally, and it is important to understand it clearly. Ice contamination, sometimes referred to in aviation incident reports as blue ice, is a real phenomenon. It occurs when a leak develops in the external waste system of an aircraft, typically around a service panel seal or a pipe joint that has degraded over time. At altitude, the leaking waste freezes immediately on contact with the exterior of the aircraft in the -50-degree air. It forms a solid mass of frozen waste and blue chemical solution attached to the fuselage. During descent, as the aircraft drops into warmer air, that mass can detach and fall. There have been documented cases of blue ice striking buildings and gardens below flight paths around major airports. It is rare. It is not a normal part of aircraft operations, and when it is discovered, it is treated as a serious maintenance failure requiring immediate investigation. But it does happen, and it is the closest thing to the myth of waste being dumped from aircraft that actually exists in reality. Now, here is something worth thinking about that takes this story in a direction most people would never expect. The vacuum toilet system used in modern aircraft did not originate in aviation at all. It was developed for use on passenger trains and ships, where the same core problem existed. How do you remove waste efficiently from a moving vehicle without using large volumes of water and without relying on gravity alone? The answer, a pneumatic system driven by pressure differential, was adapted for aviation use and first widely introduced on commercial aircraft during the 1980s. Before that, older aircraft used a recirculating blue liquid system that worked more like a chemical toilet than a true flush system. The waste was not removed to a separate tank in the same way. It was chemically treated in place and recirculated. The smell was, by all accounts, considerably worse. The shift to vacuum systems was one of those quiet revolutions in passenger comfort that happened entirely out of sight and was never once mentioned in an airline advertisement. There is also a dimension to this story that connects directly to public health in a way that became impossible to ignore during the years of global pandemic. Aircraft lavatories are small, enclosed, and shared by dozens or sometimes hundreds of passengers over the course of a single flight. The waste system, if it develops even a minor leak or seal failure, creates a potential pathway for the spread of pathogens between passengers. Aviation health regulators and aircraft manufacturers have spent considerable effort designing systems that minimize this risk. The pipes carrying waste from the lavatory to the holding tank are maintained under negative pressure, meaning that any leak tends to draw air inward rather than expel contaminated air outward into the cabin. The lavatory itself is ventilated separately from the main cabin air system, with its own dedicated extraction fan that draws air directly overboard rather than recirculating it through the main cabin filtration system. Most passengers have no idea this separation exists, but it is a deliberate and carefully maintained boundary between the lavatory environment and the air they breathe in their seats. The lavatories themselves are also subject to a level of engineering scrutiny that would surprise most users. Every surface material is chosen for its resistance to the cleaning chemicals used by ground crews, which are considerably more aggressive than household cleaners. The bowl material has to resist staining, scratching, and bacterial adhesion across tens of thousands of cleaning cycles. The flush valve, which is the component under the most mechanical stress given that it opens and closes hundreds of times per flight, is designed to a service life measured in hundreds of thousands of actuations. When a flush valve begins to fail, the symptoms are usually a weak or incomplete flush, which increases the risk of waste remaining in the pipe rather than reaching the holding tank. Maintenance crews are trained to identify these early signs and replace the valve before it causes a more serious blockage. A blockage in an aircraft waste system mid-flight is a genuine operational problem. The lavatory affected has to be taken out of service immediately. On a short-haul flight with multiple lavatories, this is an inconvenience. On a 16-hour-long haul flight with a full passenger load, taking even one lavatory out of service significantly increases the burden on the remaining units and can create a cascading problem if the blockage is not isolated cleanly. Engineers who design these systems think carefully about redundancy, ensuring that a single point of failure cannot disable the entire waste network. The pipe layouts, valve configurations, and tank connections are all designed so that one section can be isolated without affecting the others. The broader point is that the systems managing waste on a commercial aircraft are the product of decades of engineering refinement driven by two competing pressures. The first is hygiene and public health regulation, which demands that waste be handled in a way that poses no risk to passengers, crew, or the communities below. The second is the relentless commercial pressure to reduce weight, reduce water consumption, reduce turnaround time, and reduce operating costs. The vacuum toilet system, the sealed waste tank, the rapid ground servicing operation, and the chemical treatment facility at the other end are all solutions to both pressures simultaneously. There is one more thing worth knowing. The people who service aircraft waste tanks are among the most underappreciated workers in the entire aviation industry. They work in all weather conditions, at all hours of the day and night, handling material that no one else wants to be near, under time pressure that leaves almost no margin for error. A missed waste service means a full tank on the next flight. A full tank on a long-haul route is an operational problem with no good solution once the aircraft is airborne. The ground teams that prevent that from happening are as essential to the smooth running of global aviation as any pilot or engineer. That is what strikes me most about this system. The parts of aviation that passengers never see, never think about, and never thank anyone for are often the parts holding everything together most quietly and most completely. Now here's a question that connects directly to what we just covered. If the aircraft has to manage waste, water, and chemical systems across a 16-hour flight, how does it manage the air inside the cabin itself? Where does that air come from? How clean is it really? And what happens when the recycling system that keeps it breathable starts to struggle? That answer is already waiting for you in another video.